Good day, Year 11 Maths students. This video is for Chapter 4a, Hyperbolas. In this video, we'll be firstly looking at the basic function y equals to 1 over x, along with the general shape of the hyperbola, the key features including the asymptotes of the function. Then we'll be looking at the more general function and to understand the dilation factor, reflections, as well as translations. After that, I will be using an example to show you how to sketch an hyperbola. Okay, now let's get started. Firstly, the basic function y equals to 1 over x. So here it is obviously that you notice the x is at the position of the denominator. Okay, so we know that x denominator that simply tell us you cannot be equal to 0. And we know that if the denominator of a fraction equal to 0, the whole fraction becomes undefined. When it comes to sketch the graph of an unfamiliar function, we can often use this technique. Okay, by create an xy table. This concept is not new. So create xy table. You assign some x values. In this case, I'm just assigning some simple values with both negative, positive, and 0. And then you substitute each of the x values into the function y equals to 1 over x to find out the corresponding y value. So for example, when I substitute x equals to negative 2 into the rule here, I get 1 over negative 2, which is negative half. Similarly, substitute when x equals to negative 1, put in there 1 over negative 1, it is negative 1, and so on. Where you notice that when you substitute x equals 0 in there, you got 1 divided by 0, which we know that it is undefined. It is impossible. You cannot have a denominator equal to 0. Therefore, the y value is NA. You're unable to determine. Okay? So when it comes to sketching the graph, firstly, we can plot those points. Okay? So such as when x equal to negative 2, y equals to negative a half. So that is the point. And then you have y equals to x equals to negative 1, y would equal to negative 1. When x equals to negative a half, y would equals to 2, negative 2. Okay, and then because when x equals 0, there's no y value can be found, we have to leave it blank. Okay, and we have to make sure that there is no way that we can get y equals to any number when x equals 0. So that x equals 0, it is a vertical asymptote of the graph. Moving on, when x equals to half, y equals to 2. When x equals 1, y equals to 1. When x equals 2, y equals to half. Okay, so you have those points that plotted, and then you do a curve for each part to try to join those points. Where you notice that the hyperbolas will form this pattern, the two curves that you sketched forms a diagonal way. Okay, so we call this a rotational symmetrical. Okay, it's a rotational symmetrical graph. It's actually symmetrical about the center of its rotation. Okay, the other key feature that for hyperbola, which is very important, are the asymptotes. Okay, so here we have the two asymptotes, the vertical asymptote and the horizontal asymptote. The vertical asymptote, we have already talked about that. We know that x equals 0, it is a dotted line or a boundary that we need to make sure the graph will never get or never touches, because here the y is NA. Okay, remember that this is a two-dimensional plane. Every single point on the plane must have an x coordinates with the corresponding y coordinates. Okay, since every single point on this on the y-axis will have x equals 0, and we know that it's impossible for our function to touch. Therefore, no value can be found. So we have to make sure that this dashed line is labeled so that teacher know that this is called the asymptote that your graph will never touch. You have to show it. And then we have the horizontal asymptote. And how are we going to interpret this horizontal asymptote? Well, it is because x can never equal to 0, right? We know x cannot equal to 0. Therefore, y cannot equal to 0. Okay, so if you want, you can transpose this equation. You can transpose this equation y equals to 1 over x into xy equals to 1. Basically, I'm multiplying x both sides. Okay. In this case, we can see that there is no way that y would equal to 0, right? So, or no point of your graph should be touches the x-axis since the product is equal to 1. Okay, so where you can see that the key feature for the hyperbola is its general shape along with the two isotopes here. Now we're going to investigating the general function of the hyperbola, which is y equals to a over x minus h plus k. So here you notice that I have put three parameters here, a, h, and k. Similarly, like the parabola case, so we're going to look at each of the parameter to understand the role it plays in changing the shape. Firstly, we have the a here. A, it is called the dilation factor. And you notice that I'm using this symbol, okay? So this partition look symbol is called the absolute value symbol. Basically, for any of the numbers absolute value, we just want to find its magnitude, okay? So all real numbers will have directions and magnitude. Okay, for example, a negative number or negative 5 will have a direction which is negative that tells you its opposite, and the magnitude, which is the size of the number, that is 5. The absolute value symbol basically only wants the number's magnitude. So we totally ignore the direction of the number. Therefore, if you got a negative number, for example, negative 5, the absolute value of negative 5, it is its magnitude 5. And the absolute value of a positive 5, it is also its magnitude 5. Okay, so here the absolute value means we regardless its sign, its direction. Okay, so it's just the size, just the magnitude. So if the absolute value of a is greater, you will see the graph is actually dilated away from both the axes. Okay, so this is some patterns that we found in class. Okay, so here I'm using a decimal, create a little diagram. So where you can see that the orange one is y equals to 0.5 over x. The red one is y equals to 1 over x. I'm zooming a bit here. As the green one, that is y equals to 3 over x. So you can see that as the absolute value or the absolute value here for a that increases, you can see that the general curve of the function that actually moving, or we say are dilated away from the axis or away from the center, if you would say away from the center. Okay. Also, you notice that no matter how the value of a changes, the two isotope x equals 0 and y equals 0 did not change. Okay, so you can see the isotope did not change no matter what a value will give you. Okay, which actually makes sense because it doesn't really matter the value of a. You cannot have x equal to 0, right? And then hence y can never equal to 0. The parameter of a also controls the reflection here. If a is a positive number greater than 0, and you can see that the hyperbola will be located in quadrant 1 and quadrant 3, but we're trying to avoid using the quadrant because later on when we talk about the translations, it won't be in the quadrant 1, 3, or 2. Okay, so let's say if we treat these isotopes that we have, the isotope has split the whole plane into 4 parts, we can now say it is on the top right. That's a top right. That is, this is the top right corner. That's the bottom left. Okay, so when the parameter of a, when a is greater than 0, for example, y equals to 1 over x, this is positive, you will have the graph that located on the top right and bottom left with respect to the isotopes. When you have a, it is less than 0. For example, here you have y equals to negative 1 over x. The negative you can put on the top. Okay, remember? In this case, your graph actually have reflected And you can see now it's on the top left and the bottom right. Okay, it's right the opposite. Okay, so understand what happened to the negative. It will potentially reflect the whole graph. But one thing is certain, that for all hyperbolas, the two parts of the curve always locate diagonally, and they are always rotational symmetrical about the center of the two isotopes here. Okay, so the center of the two isotopes. Moving on to the last key feature here, which is the isotope itself. Okay, so if we got the general form here, you notice here I have the minus h at the bottom plus k after that, after the fraction part. This actually tells us the translation. Okay, more specifically tells us the isotopes. So in this case, you can see the isotopes is no longer the two axes, but the horizontal isotope now changes into y equals to k instead of y equal to 0. Because in order to interpret this, we can say, since the whole fraction here can never equal to 0, therefore y can never equal to k. Therefore, y equals k will be the isotope, will be the invisible boundary or the dotted line that the graph will never meet. Okay. Similarly, with the vertical isotope here, x equals to h instead of 0. And then in order to interpret this, x minus h is at the denominator. So we need to make sure the actual denominator can never equal to 0. Therefore, x can never equal to h. So when x equals to h, that becomes impossible. You can't have any of the graph that is touches that dotted line, right? Which is the vertical isotopes here. Okay. All right, now guys, here I've just created this Desmos animation to let you have a look about how the graph actually is changing along with the two isotopes here. Okay, so as you can see that the isotope is always moving or sliding along with the graph, and it's important that you always sketch an isotope as it's part of the hyperbola graph. It also helps you to locate the two curves more accurately on the plane. And just to summarize here, the horizontal isotope, which normally is the constant after the fraction part, okay, after the fraction part, in this case y equals 5, which is because here you have a plus 5 there, that's k. And the vertical isotope will be the number sit along with the x term here as the denominator. Okay, so if you have x minus 3, then 3 itself is the isotope. If you have x plus 3, however, and then the not the plus 3, but the negative of it. Okay, so it's negative. Okay, so it's opposite. So this is negative 3. All right, now let's take a look how we're going to sketch our hyperbolas. So it involves 3 steps. Step 1 is to locate the isotopes. This is the very first step, guys. Okay, so make sure you label the isotopes on the plane first, because it will help you to locate where the graph will be, and also help you to determine whether we have any x or y intercepts. So this is sort of give you a rough idea what the graph will be located. Okay, so here we're using this example. Sketch y equals to -1 over x minus 3 plus 2. We're going to recall the general form here. Y equals to a over x minus h plus k. Therefore, a it is equal to -1, h equals to positive 3, and k equals to 2. We know the horizontal isotope is just y equals to k, which is y equals to 2. The vertical isotope, that is x equals to h, so which is x equals to 3. Okay, so here you notice that I have sketched x equals to 3, y equals to 2, firstly on my plane. So I know that the graph is either forms this diagonal way or this diagonal way, right? So either way. And then we're going to look at the next step. Okay, so the next step is to check the general shape of the hyperbola, meaning whether it is located on the top right, bottom left, or top left, bottom right, okay? That depends on the sign of A. So here we can say A is -1. Since A is -1, that you can say the graph will be located on the top left and the bottom right, okay? Therefore, I'm going to do a rough sketch, top left and bottom right from the center of the two isotopes here, okay? Now we see that this graph will have an y-intercept and an x-intercept. Okay, the final step, step 3, is to determine the x and y intercepts here. So when, in order to find the y-intercept, we substitute when x equals 0. You substitute that into the rule, into the equation, and then you find out y would equals to 7/3. So the y-intercept here is going to be 0, 7/3. In order to find the x-intercept, you're going to substitute y equals 0 into the equation. Here is just a technique that I use. Okay, since you have a -1 over x minus 3 equals to another constant. -1, it is the dividend. X minus 3, it is the divisor. -2 is the quotient. And if we keep the dividend on the top, not change the dividend, we can actually swap the divisor and the quotient since it is divisible. In this case, if we swap them, save us a bit more time. Anyway, and we got x minus 3 equals to a half, so x equals to 7/2. So the x-intercept here is 7/2, 0. Okay, so once you have all these key features have shown on the graph, okay, you do a final check. Do we have the two isotopes written and labeled? Yes, we did. Yeah, and we have the general shape of the graph correctly. Yes, we have. And then make sure that we have labeled the intercepts along with its coordinates. Okay. Now, if you are sketching multiple graphs on the same plane, you also have to label the equation next to a graph. Okay. So this will be all for chapter 4a, hyperbolas. I hope you enjoy this video, and if you got any questions, make sure you ask me in class or come to Mr.Liu support. Thank you guys. I'll see you in the next video.